Welcome back. Problem 8-28. This problem is taken from chapter 8, that is combined loading, from the book Mechanics of Material by R.C. Hibbeler. Statement of the problem is the cylindrical post having a diameter of 40 millimeter is being pulled from the ground using a sling of negligible thickness. If the rope is subjected to vertical force of 500 Newton, determine the normal stress at point A and B. Show the result on volume element located at each of these points. So you can see this is a cylindrical post, clear, and it is being pulled from the ground by using a slick that is negligible, and a force of P is applied on the rope, and the value of P is 500 Newton. So you have to find the normal stress at point A and B. So let's start with the solution. So if you cut the post at this and draw the free body diagram, so it will be like this. This will be the post. Clear. There is a load of P at this end. This is P. This is the diameter of this post, and this diameter is 40 millimeter. 40 millimeter. Okay. So when you cut it, you will be having a normal force that is acting at the center of this, and let this force will be N. There will be a shear force which is V, and there will be a moment as well which is M. Okay, so you can see that for finding the shear force, sum of all force along horizontal direction must be equal to 0, and force in this direction is taken as positive. So only V is acting horizontally and there is no other force, so it means that horizontal shear force is equal to 0. Now we'll find this vertical force N. So for that, sum of all forces along y direction must be equal to 0, and upward force is taken as positive. So two forces, one is P and other is one N. Their sum must be equal to 0. So P minus N will be equal to 0. So it means that N is equal to P, and P is given as 500 Newton. Okay, now we will find this moment. Clear. So sum of all moment about, let this is the axis. Clear. This is the vertical axis X. So sum of all moment about X is equal to 0, and taking the counterclockwise moment as positive. So you can see that moment about X is this one reaction moment which is counterclockwise, so it will be plus. So plus M. The second moment is this force, clear, into perpendicular distance is this one, and this one is this distance is radius, which is 40 divided by 2 is 20 millimeter. So 20 millimeter. And this is producing clockwise movement, so minus P into 20 millimeter. So 20 millimeter in meter is 0.02. Their sum must be equal to 0. So from here you will get movement will be equal to 0.02 times P, and that is 0.02 multiplied by 500, and this movement comes out to be 10 Newton into meter. So now you have all these values. So you can see this is a case of combined loading. I will write it. Combined loading. How? Let me show you. You can see that there is a axial force N, and if you move this P to this axis, so there will be a moment as well. So this normal force will produce normal stress, or axial force produce normal stress, and this moment will also produce a bending stress. So you will get the stress will be equal to P divided by A or N divided by A, because N and P are both are same, plus minus M into Y divided by I. Now we will find I and A for this circular or cylindrical post. So area will be equal to area for this circle will be equal to pi r square. So pi multiplied by r is 20 millimeter, which is 0.02 meter in its square. So you will get area will be equal to 1.256 into 10 raised to power minus 3 square meter. Now for I for this circular cross section is equal to pi by 4 r power 4. So pi divided by 4 multiplied by r is 0.02 and its power 4, and when you calculate it, it will be equal to 0.1256 into 10 raised to power minus 6 meter power 4. Now you have A, you have I, you have P, you have M. So you can see that here this is the load, clear, and this is the load, and there is a movement at this, clear. So on the side of B there will be a compression, it will be like this, clear. There will be a compression on this side and there will be tension on this side, okay. And you can see if I draw the cross section of that and its axis horizontal and vertical, so this will be its point A and this will be the point B. Why? Because you can see that the movement will be like this. So this will be the neutral axis, clear, and this movement is about this x-axis, which is shown over here. So B points lie from at below, and this is, or you can see if you look at over here, so this is point B and this is point B and this is point A, and it will bend like this. Bending moment will be like this. So this is the neutral axis, clear. So sigma at point A will be equal to P by A. If we take plus, so M into Y divided by I. So P is given as 500, area is 1.256 into 10 raised to power minus 3, plus moment is 10, and Y, what is the Y? Distance from Y till neutral axis till point A, so Y is equal to 0 divided by I, which is 0.1256 into 10 raised to power minus 6. So from here you will get sigma A comes out to be 0.398 megapascal. Now we will find the bending stress or normal stress at point B, which is equal to P by A minus M into Y divided by I. Why we have taken minus? Because I have already told you that due to this movement, this upper portion will be in compression and this will be in tension. So this point B will be in compression. So we are taking minus sign. So P is 500 divided by area, which is 1.256 into 10 raised to power minus 3 minus 10 into, now you can see Y is this distance, YB. Distance from neutral axis till point B, and this is equal to radius, and that is 0.02. So 0.02 divided by I is 0.1256 into 10 raised to power minus 6, which will give you sigma B. And when you solve it, you will get sigma B comes out to be minus 1.19 megapascal. So these are stresses at point A and B. Now we will represent them on differential element. So if we take the element A like this. So sigma A is positive, so it means that this will be the normal stress. Sigma A will be equal to 0.398 megapascal. Now for point B, if you draw the stress element or element of at portion B, so you can see this is minus compressive, so it will be minus B. So sigma B is equal to minus 1.19 megapascal. We will write positive because this sign shows you that this is in compression. So this was for B and this was for A, and that was all about this problem 8-28. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Also in description box I have mentioned all the links of the all playlist, so you can visit and you can watch your required chapter videos. Thank you for watching.